You'll see notification come up from your screen. Right. Okay, let me know if you're not able to see anything on your screen. You should looking at the PowerPoint slides for EE3279. So there's a prerequisite for this module. EE3179, Introduction to Fluid Mechanics. All right. So may I know your previous lecturer who is teaching you on this module, 3179? Is all of you sharing the same lecture?
Dr. Danny, sir.
Oh, okay. So all of you are taught by Dr. Danny previously?
Yeah.
Okay, good. All right. So yeah, Dr. Danny, she's a good lecturer. So I believe all of you are in good hand. Okay, so what does this 3279 do? It's just it is an upgrade of the previous one, 3179. We look into a few more chapter linked to 3179. So throughout this semester, we will look at some keyword. The first keyword is finite control volume analysis. And then we will look at viscous fluid and fluid machine. Right? We have 5 learning outcome. Each learning outcome will come out in your test or final exam. Of course, final exam will cover all. So these are the keywords that you need to pay attention when I brief you on the test later on. Okay, so first learning outcome will test your understanding and in applying the control volume method, finite control volume method for 2D scenario. Although here we will cover 2D and 3D. However, in your test or final exam, we will only cover 2D cases, right? So for LO2 or learning outcome number 2, we will look at losses in a fluid. The third one, we look at lift and drag forces on the body. And then the next one is we will use some tools to simulate some of the problems. So meaning I will introduce you a very fundamental ANSYS software. Right? I give you some assignment, then you use ANSYS to solve the question. Then after that, the last one is the fluid machine, where we look at pump and turbine in your last chapter. Okay, so you may contact me on every Wednesday if you have any question. So you can contact me 1 to 3 p.m. or maybe 2 to 3 p.m. WhatsApp me. You have my contact number. You have my email. So you manage to reach me out. Okay, so just to recap, what is the context of your assessment? So your assessment consists of 40% coursework and 60% final exam. For coursework component, you have a midterm test or your test 1, assignment, and lab report. So you have 3 lab. Okay, so it depends on the scenario of we have in Malaysia. So if we continue to lockdown, then we will give you some online material. Maybe we'll have a free streams session where I go into lab and then I conduct experiment, you follow along. All right. Then 60% for your final exam. So just give you some guidelines. Final exam will consist of 3-hour session in the same day. So let's say if the exam start on 9 o'clock, you will start solving paper 1 in session 1. 9 o'clock until 10:30, you solve question 1 and question 2. Then after that, excuse me. Then after that, you submit the answer to the Moodle. Maybe 10 to 15 minutes you submit and go for a short break. Then you come back on 11 o'clock. So from 11 o'clock, you solve for second paper, 1.5 hours. You solve question 3 and question 4. All right. Then you given 10 to 15 minutes to submit, and then you end the final exam. So this is how we will do it. Same with midterm test. Of course, midterm test, we won't have 4 questions. We only have 2 questions. All right. So 2 questions means 1.5 hours. All right. For this module, you need to score total marks 50 out of 100, mean 40% plus 60. You need to have a minimum 50%. Coursework, you need to score 20 out of 40 at this component. So before final exam, I will release the marks for 40% coursework total marks, and so that you know how many points you need to achieve for your final, for your target grade. All right. Passing mark for final exam for this module is 30 marks out of 100, meaning question 1, question 2, question 3, question 4, add up 100 marks. You need to score at least 30 out of 100 to pass the final exam. Of course, there's one more criteria just now I mentioned. You need to get at least 50% out of 100% for this module. So there are 3 criteria. So always check whether you score 50% of your coursework, 30 out of 100 for your final, and then your marks must more than 50. Okay. We will cover 7 topics, 7 chapters for this module. Today we'll look at fluid kinematics, and then chapter 2, finite control volume, and so on. Okay. We will have 3 lab components. So it depends on, again, on the situation we have. So we might conduct all 3 lab in the same day. And then I will brief you through, guide you through how to prepare the report. Okay. This is the textbook that I'm using. All right, so chapter 1, we look at fluid kinematics. The word kinematics means something that is moving, and it link up with the fluid. So fluid here, it means fluid means element, fluid not necessarily water, but fluid, it means something that is in liquid, or it can be air. So you will look at what is 3D scenario and 2D scenario, and then we will look at streamline if we have time today. Okay, I will go a little bit slower. Short lecture. I hope we have a short lecture today. Right. All right. Stop me after 45 minutes if I didn't stop. So we'll go for a short break. Kinematic of fluid motion. There are 3 points that you need to remember. So when we talk about kinematics, like what you see on the screen here, there is modeling done using simulation software. So when you study the motion of the fluid on a body or on a surface, you will look at velocity, you look at acceleration of the fluid, and then you need some visualization of the motion. Okay, so today we will look at one of the tools to help you to visualize the motion. All right, velocity, acceleration, you have to know the difference between these 2 terms. All right, now we start with something a little bit more deeper. In this chapter, or in this module, we will deal with fluid particles. Where on the screen here, you will see the simulation software is showing some graphical data that represent by a ball or spherical element. So we'll look at what is happening to the flow when you get contact with a certain surface. Okay. And this is another one. So the one that on the right here is a 3D simulation software or 3D analysis. On the left-hand side here is a velocity vector that you see that crossing some surfaces in here. You see that the flow is get contact with a 2-sphere block here, right? And you see there are some changes of direction. When you talk about magnitude and direction, you need to link with the vector. So if you're weak in vector, please go back to your mathematics, advanced mathematics, or maybe you need to go back to engineer ma to review what is vector. Okay, so I assume you already know what is vector already, when you come to this stage. Okay, the first one, we look at your tutorial question number 1, which is ask you to a simple question. What is the example of fluid properties? So example of fluid properties, we look at density, pressure, velocity, and acceleration. So we start with density. We start with this symbol, rho. P we use for pressure. Sometimes we use capital, sometimes we use small capital. Velocity, it depends, but most of the time you see V, it represents velocity. And sometimes when you talk about vector, it means position. Acceleration is A, capital A, all right, unless it's is mentioned in the slides, we use other symbol. Now, before we move on, we need to start with Cartesian plane. Let's say in this module, we assume all the direction to the x is positive, all the direction to y is positive, all the direction to z in this direction is positive, the origin is 0. So if anything deal with x direction, let's say if velocity, we will use u. If something deal with y direction, either is velocity or some displacement, we will use v. And if link with the z direction, we'll use w. Okay, so u, v, w is a symbol that we use. Every time you look at u, it means that direction is happening on x-axis, along x-axis. If you look at v, it means something happened to y. If it happened to z, it is w. So all this notation is important for you to score some marks when you come to test or final exam. All right, so be careful, be careful on the notation that you write in your equation. So far, everything is very simple. Okay, the next one is called field representation. It is called coordinates that we use. So we need to describe the behavior of flow or kinematics of flow. We need 2 parameters to help us at least. The first one is called coordinates that represent by your x, y, and z. The third one is time. You combine these two, you will get exact location in the 3D domain. Okay, so you need 2 information to solve any question in this module. You need coordinates information and you need time information. All right, so x, y, and z, you need some coordinates, and you know that you have 2 types of coordinate system. One is called Cartesian, which is represented by x, y, and z. Another one is called radial coordinates. Radial coordinates represented by r and theta. Okay, we have 2 coordinate system here. So this one is called Cartesian system. This is called radial coordinate system. Most of the time, but no, don't worry. For this module, I will set question most of the time in Cartesian. Okay, yeah. All right. Just recap what you learned in your 3179. If you look at the diagram here, you are seeing some domain here. On the right-hand side diagram, you will see that you have x direction, y direction, and z direction. Be careful on the orientation. Sometimes we will change the x location to a certain point. So, but however, the axis will always perpendicular to each other. So in this case, x is in this direction, y is in this direction, z is in this direction. And when you deal with vector along x, we use I hat. Vector along y, we use j hat. Vector along z-axis, we use k. So from today onwards, you always see vector form equation. All right, make sure you understand every time you see what is I, what is j, what is k. All right, and then you will see some diagram like what you see here. The vector, you know that when you have a resultant force, V, you always can split them out. If it's in 2D cases, you can split in x and y direction, okay, by a theta. All right. So this is just a recap of what you learned previously. So if you want to break this V to X component, V and X is cos theta. Okay, so you need to call your trigonometry understanding. Cos theta equal, okay, let's say you have a triangular. This is a right angle. This is your theta. So you need to recall what you learned in trigonometry. Let's say this is your x, this is your y, and this is your vector, maybe v. So cos equal to x divided by v. Sine theta equal to y divided by v, and so on. Tangent, so on, yeah? So tangent equal to y divided by x. So far. So if you want to expand this v vector in x direction, so v vector represent as v cos theta. Okay, so if you look at this one, yeah? So if this is your v, you can represent what is this vector. This vector is v cos theta, and there's a one more component in y, will give you v sine theta. Right? So you need to know on all this. If this one convert to 3D dimension, then it will be more complex. Right? Okay, vector form. By expanding what we learned just now, I already explained. Your vector can represent by x direction, y direction, and z direction. If you have a bracket, means that your u velocity in x direction is related to x, y, and z and time properties. Normally, when we write equation, we seldom write out this function. We normally will write v equal ui hat plus v j hat plus w k hat. Okay, I think this one you familiar. Any questions so far? Any question you are not agree, or it seems confused to you?
So far, no, sir.
Good, huh? Okay. All right. So you have any question, just stop me and ask. Okay. So again, recall the velocity vector in three-dimensional, u, v, and w, with the I hat, j hat component. And again, on the left is a Cartesian plane. On the right, when you tell the history of a particle from t equal to t, or time t, to the next time, or 0.1 to 0.2. 0.1 time is t, 0.2 equal to t plus delta t. So you have to be sensitive to all the notation. So delta t means small changes of time. If you look at d, d means a leap, also change of time, but will be more on a differential dimension. If you look at changes of t, delta t, then this one will be bigger. So this one is a partial differential or partial, very, very small changes. This one is a little bit bigger, but than this one. All right, and this one is the most biggest dimension. Okay. So here is a particle path. So if particle A move from point 1 to point 2, you can link them with red lines like what you see here. We call it path. All right, path, and this path you can solve, or you can define it by using the equation that you see on the screen here. V in the vector I, vector j, and vector k to represent the motion towards time. So the R arrow here, RA, with the T here, it just represent a position vector. Okay, so far we are only touching on the vector dimension. Okay? It's just a recap. Bring back all the memories that you learn from your advanced mathematics and calculus. Then we slowly will apply what we learn into this module. Okay. Right. So another equation that you normally will see in this module is that we always like to have a differential equation, where when you define a velocity, you write the changes of r divided by t, you'll get velocity. So in this case, if you want to define the motion of the fluid particles, then you write dr over dt, then we know that you're going to define the velocity motion. Because once you write dr dt, you can integrate from one point to another point. If you integrate this one, you are integrating the time, t1 and t2. Just bring back your advanced mathematics or calculus skill. So t1 to t2, you integrate, you will get the constant value of that particular things. If you cannot get, then you will just add some constant parameter there. Okay. Yeah. So bring back your steps operation procedure plus constant value. If you don't have the boundary layer here, then you have constant value plus your answer. Okay. Okay, this is just a recap. Velocity always have direction and magnitude. So you want to find, if you're given a vector, you're able to find a magnitude by this equation. You square root the u component, the x component, y component, and z component. U square plus v square plus w square. So this is the vector magnitude just now. Okay, and we always have a positive magnitude. Okay, so remember, if you are told to solve for the magnitude of a certain vector, write this symbol, two straight line or straight bracket, v equal to square root of u square plus v square plus w square. By writing this equation, you score 1 mark. Okay, yeah, it's very easy to score this for this module as long as you understand, and then you write the general equation, you will score some marks there before you solve the question. Okay, we start to look at application of vector for this module. So if you don't only download the tutorial question, you may look at question number 7. Yeah? So it's exactly the same as what you see on the screen here. All right. So you're given a velocity field with the equation v equal to, and let me change my pen color. Okay, v equal to this equation, v0 divided by L minus x I plus yj, where VO divided by VO and L is a constant. All right, so this is application of what you learned so far. All right. This tutorial question asks you to do something. It asks you, at what location in the flow field is the speed equal to this constant value V0? Right. Now it looks complex. Don't worry, I will guide you through. It's just you need to recall what you learned previously. You already learned about this. So you already passed the previous module, so you have the skill already. Only need to recall back. Then you need to sketch the velocity field of this one. But however, the domain that you need to only sketch is more than 0. More than 0, and then you need to draw arrow to represent the flow velocity, to represent the location. So at this moment, we are looking at a vector equation or a velocity field. We call it velocity field. Okay, before we solve, I want to ask a question. Okay. Let me check the release. Raj, are you there, Raj? Raj, are you there? Raj? Calling for Raj. Raj, are you there? Okay, Raj is not in the class. Dinesh, are you there? Dinesh, are you
Yes,
there?
sir. I'm here.
Okay, good. Now back to our screen here. Let me check what happened to Raj. Okay, Dinesh, you look at the screen. You're able to see my PowerPoint slides?
Yes, sir.
Okay, I already highlight the velocity field there.
Yeah.
My question is like this. You look at the velocity field. This is a 2D scenario or 3D scenario, and why? This one is a 2D scenario or is a 3D problems? It's a 2D problem or is it 3D problems? And why? Why do you say?
I think this is 2D, sir.
Why? Why you say that it's a 2D question or 2D problem? Why? What's the reason you say it's a 2D? There must be a reason, right? Or you're just guessing, oh, this is 2D. Cannot, you already come to your like year 3 already, yeah. So of course, you when you become my student, I will expect or train you to be think a little bit more. Yeah. Oh, I'll always ask you why. You need to answer. Okay. Or you don't know the answer.
I don't know the answer, sir.
Okay, good. Shirley, are you there, Shirley?
Yes, sir.
Okay, you look at the screen here. You look at the velocity field or the equation. What is this problem? This is a 2D problem or 3D problem? Why?
Based on the velocity fields that given, right?
Yeah,
I think it's 2D because like they already have I and J only. They don't have the K.
correct. Good answer. Okay, Dinesh, you hear what Shirley said just now?
Yes, sir.
Yeah, so you understand why this is 2D, yeah?
Yeah.
So when you have a 3D, you'll get something xi plus yj, sorry for my writing, I'm writing using my mouse, and k, ijk. You have this form, then you become a 3D scenario. Okay, so by looking at the question, you know there's 2D, then you can relax a bit lah, because 2D it will be a little bit more simpler to solve. Huh? Okay, how to solve? Huh? Okay, so when you solve question, most of the time you need to extract the equation out. So when you extract equation out, all right, you will see the highlighted equation. V equal to V0 divided by L and minus xi plus yj, where the VO divided by L is a constant, right? You constant divided by constant, you still get a constant value. So constant value. All right, so again, you write the general equation, you copy the equation, this one, from the question, then you write the general equation, V equal to Ui plus Vj plus Wk, you get 1 mark. By just writing out the general equation, you'll get 1 mark in your answer. So by comparing the question, by comparing on the screen, I'm going to ask question again. Let me check. Okay, Raj, your mic is working now?
Yes, sir. Yes, sir.
Okay, Raj, you look at the screen here. Can you tell me what is the U? What is the U value in this case? What is U? U equal what?
So is that stands for what, or you asking the value?
Yeah, I mean from the screen here, you comparing two equation. You know that you have two equation there, right? I'm asking you what is U from this equation? What you can tell me what is U? U equal what?
So as I know, initial velocity, is it?
No, you have two equation. Then I already put side by side. What is the U represent? U equal to what?
Oh, okay, I get it, sir. The
Ah,
volume or the density, is it?
no. I mean, okay, let me try to ask somebody else. Who else not yet answer my question? Yong, Yong, I haven't asked you, right? Yong, are you there? Yong, are you there? Hello, Yong, are you there? Okay, never mind. Maybe Shirley can help to answer this kind of question. So Shirley, what is the U value that if you compare side by side this equation, what is U value?
I think the U value is that the initial value for the velocity divided by the L, is it? So
Yeah, L, okay,
the one multiply with the negative x.
correct. So you understand Dinesh and Raj?
Yes, sir.
If you expand
Yes.
this equation, what you write? What you get? VL minus X. If you time this one, you get minus I plus, apologize again, I'm writing using my mouse. YJ, oops, sorry. Apologize for my writing. Okay, so if you compare side by side, this one is your u. Your u is minus v0 x divided by L, or you can put your x to the side. You represent as u. Dinesh, do you get it?
Yes, sir.
Okay, then now you tell me, what is v value? What is v? You say you understand, right? Proof that you understand. Surely you know the answer, right? You don't need to tell me, but do you understand the v value?
You mean me, sir?
Yeah, surely you understand, right?
Yes.
Okay, right. You don't need to tell the answer. Okay, then Dinesh, what is the v value? Dinesh, are you there?
Yes, sir. Give me
So
a
what is v? What is v? Dinesh, you are doing something else behind the screen? Or you're busy with something?
No, sir. No, sir.
Yeah. You understand the what is u or not? Do you understand what is u? Do you understand what I'm trying to ask, Dinesh?
No, sir.
You don't understand what I'm asking? Okay. You look at the screen, right?
Yeah, yeah.
I'm asking. You are looking at two equations.
Yeah.
What is the value of u? Just now, the Shirley already tell the answer. What is u value?
It's VO over
Over what?
L times by
Okay.
negative x.
Okay. You understand how you get there, right?
Yeah.
Okay. Now tell me, what is v?
VO over L
Okay.
times by y.
Okay. Correct. Excellent. Now, Raj, are you there, Raj?
Yes, sir.
Okay. You look at the screen here. What is w? What is w and k value?
Sir, the k is like we need to same like the first one, sir. We need to put there. Then we just simplify. Then we get the same one, sir.
Yeah. Then, okay. By looking at the screen, what is the value of w and k component? What is the w value?
W value is actually the same, v over the density minus x, and then we need to put the k at outside, sir.
That is
Am I
your
right?
answer. That is your answer.
This is my answer, sir.
Okay. 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 I check back on. Okay. Let me check whether our friend is there. Yong, are you there? Yong, this is the second time I'm checking. Again, this is a recorded video. Young, what happened to your mic? Okay, never mind. For this lecture, I will give you time to sort out your mic, Young. Okay, Dinesh. Dinesh,
Sir.
okay, what is the value of W in this case? Shirley, stand by the answer. I will ask you to answer also. What is the value of W in this case? Now, we haven't go deep into further, we just scratching the skin. We haven't go deep into the content yet. Dinesh, what is W in this case?
I don't know, sir. W.
Okay. Shirley, what is the answer? What is the value of W?
There's no value for W since this is 2 dimensions.
Correct. The value of W is 0. Danish and Raj, do you understand?
Yeah, if there is 3, there will be Z, right, sir?
Yeah, so is there any Z in the equation given?
No.
Yeah, sir. I mean, I'm wrong, sir. I didn't notice.
Do you get it now?
Yeah.
Yeah, I get it because it's only two things only there.
So the general equation is a 3D equation. When you write the 3D equation, you get 1 mark. Then you need to match with the scenario that you have. So this is a 2D scenario. Of course, there is a value for W. The value of the W is 0. So if the question asks you what is W magnitude, answer 0. You'll get 3 marks, maybe 2 marks there. Okay, don't lose all these super bonus kind of question. So if you try to get along, all right, try to follow along. Okay, let me go for a few more slides, then we can have a short break. Okay. So when I write my U equal to minus VO divided by L times X, I copy from side by side. I get my U, I get my V equal to U0L times Y, and of course, my W is 0. There is a value for W, although this one is a 2D case, but when you want to represent a 2D case, the value of W is 0. Okay, there's no Z there. So again, this is a 2D problems that we mentioned just now. Then after that, we calculate the velocity speed. Again, the magnitude of the velocity for our fluid given by the equation. So when you write V equal to bracket V equal to square root of U square plus V square plus W square, you get another 3 marks there. Okay. So your V, you can write like this form. V equal to U0 divided by L times square root of X square plus Y square plus 0 because you don't have W. Okay. So these are another steps. If you do this one, you get 1 mark. All right. So if you look at this equation, it will give you some form of a shape. This is the equation of a certain shape. All right. So if you rewrite the equation, V equal to V naught or V0, you pull the L back into the equation, you get square root of X squared plus Y squared plus 0 divided by L. This actually, okay, and then you can find the location where the velocity equal to 0. Okay, one question before we stop for a break. Okay, Dinesh, this question is for you. Dinesh, you look at the screen here. And
Yes, sir.
you have v equal to v0 times the square root of x squared plus y squared plus 0 divided by L. If the question asks you to find a flow field that the speed equal to v0, if the speed in the flow field v equal to v0, v equal to v0, what is the value of this component? This equal to what? Rod, stand by your answer. The next one I'm going to ask you. Huh?
Should be 0, right?
0 equals 0. Why equals 0? Okay, I ask you a question. You will say 0. V equal to V0 times 0. What do you get? You get what?
0.
You get 0.
Yeah.
But the question asks you not to find 0. Question asks you the velocity field equal to V0. So what do you need this component to be? This value need to be what value? It's not 0. Okay, Raj, maybe you try, Raj.
So the component value is equal to 1. So if we
Yes,
multiply, we get
correct. Correct. It's 1. Okay, can you explain to Dinesh why we need to why this one can equal to 1?
because the component value, as I know, they got a square. Then if we like complete the equation also, for the final answer we will get 1. So when we times by the VO, then we will get the answer equals to 1.
Okay, my question is, I just asked you what is this highlighted component value mean if you want to get the V equal to V0. So if you compare side by side, it's very obvious that this one must time 1 so that to get the answer of V0. Dinesh, do you get it?
Yes, sir.
Dinesh, you need to polish up your mathematics.
Yeah.
You already come to your 3rd year already, so
Yeah.
there are some expectation on the mathematics. Surely you have no question, right, on why the answer is 1 equal to 1?
No, sir, I understand.
Okay, good. Okay, we have maybe 10 minutes breaks. Is that all right, or you want longer? We will.
That's okay, sir.